Hi everybody and welcome. Today we're going to be talking about trapezoids and kites. So we'll have one video for each, and your goal after watching both videos will be able to identify some key properties and solve for some unknowns based off of what we know about trapezoids and kites. So first things first, what is a trapezoid? So a trapezoid is a quadrilateral, which means it has four sides, with only one pair of parallel sides. So typically what you probably think of is something that looks like this. And using our geometry terms, we know if we make that symbol, those two sides are parallel. If we extend them forever, they're never going to cross. And that's a trapezoid. As long as there's one pair of parallel sides and it has four sides, that's what we need. Now, the most common type of trapezoid, and the one that we're going to be working with the most frequently, is called an isosceles trapezoid. So similar to an isosceles triangle that has two congruent sides, an isosceles trapezoid is the same thing. Each side length is the same. So for example, if this is 6, then this side over here would also have to be 6. So to be very, very clear about what that means, it's a trapezoid with one pair of congruent sides. Now, if we have an isosceles trapezoid, there are a few theorems or a few things that we can certainly say about them regardless of what's going on. So the first theorem is the base angles are congruent. So if we have congruent base angles, then we can say with certainty that it is an isosceles triangle. So for a proof, we could use this to prove an isosceles triangle. Second, an additional theorem is that if the diagonals are congruent, then we can also say it's isosceles. Let me write that a little bit more neatly there. So what diagonals mean is that we have our little trapezoid here, we got our parallel side, those are equal. So this side's equal, this side's equal, this angle's equal, this angle's equal. Diagonals go from angle to angle. So from here down to here, and then from here over to here. And if this is the same as this, then diagonals are congruent. So if they have exactly the same measure from side to side, those are the diagonals, they would be congruent in that case. The final thing we can say about trapezoids, so this isn't just for isosceles trapezoids, but for all trapezoids, is the following. There is a mid-segment theorem, and this tells us that the mid-segment of a trapezoid is parallel to its bases and is the average of their lengths. So for example, another trapezoid, the mid-segment is the segment that's in the mid, or in the middle. So this guy right here in yellow is the mid-segment. If the base on top is 2, and the base on the bottom is 4, how we find the mid-segment is we add the bases. So we got the 2 from here, the 4 from here, and then we divide by 2 to get the average. So that would be 6 divided by 2, or our mid-segment equals 3. So we would know that in yellow here, mid-segment equals 3. Again, add the top, add the bottom together, divide them by 2. There's your mid-segment. All right, so based off of that, a few different things that we are going to see with these trapezoids. So you might have a question like a mid-segment calculation like we did above. Another type of question that I want you to be prepared for is solving for some unknowns. So I'll pull up another example here. So we'll call this mid-segment question example number 1. And then example number 2 that we can share here is, let's say, something like this. So these are parallel, it's a quadrilateral, and this side length is 4, and this side length is 4. So based off of this, we can say that it's an isosceles trapezoid. Again, we have 2 equal side lengths. But what the question might ask us for is to solve for x, y, and z if this angle right here is 70 degrees. So what do we know about isosceles trapezoids? Well, we know that the base angles are congruent. So bottom equals bottom, top equals top. So in this case, x equals 70. Okay, so that's one thing that we solve for. But what about y and z? Well, it is a quadrilateral, so we know that everything adds up to 360 degrees. So x plus 70 plus z plus y, all of those angles on the inside add up to 360. So again, our y and z are in blue up top, and then in green, that's where I got the x and the 70 from. Okay, well, we already solved for x. We know that x equals 70, so we plug in a 70 here, a 7 here. So 360 equals 70 plus z plus y. Put some like terms together, 140 plus z plus y equals 360. And keep going. Get everything as simplified as we possibly can. And we're left with 2 variables. But if we remember, x is equal to 70, and also y is equal to z. So we can substitute one in for the other one, but basically, they're both equal to each other. So because of that, if we want to, we could say this is like 2y. And if you're like, Mr. R, how did you get that? Well, if y equals z, then wherever there is a z, we can plug a y in its place because they're equal to the same amount. So we did substitution property to do that. So because y equals z, we can replace z with y. 2 y's together get us 2y. All right, so divide everything by 2, we get 110 equals y, and if y equals 110, then z also equals 110. So those are some typical trapezoid questions that you might find, maybe solving for some angles based off of isosceles trapezoids. Maybe you have to solve for a side, but just use your properties. Remember, part plus part equals whole. In this case, we had everything adding up to 360. And then secondly, for the mid segment, it's just averaging. So if you have the top and the bottom side, the average of those two is the center.